Good morning, middle school. It is Mr. Manta here. Today's date is Thursday now, April 30th of 2020. And yesterday, you should be watching this on Thursday, April 30th. Yesterday, as you know, we had our quiz for science. And for the most part, people did really well. I was really impressed. The average grade across all three classes was around a 15 out of 20. Purdue, if you're a Purdue student, go ahead and pat yourself on the back because Purdue had the highest scores overall. Georgia Tech, you guys had the lowest scores overall, and you're supposed to be the oldest ones here. So I don't know what's going on there, but I know some of my 6th grade students need to step it up one little bit. We're going to move on today to different types of change, to a new lesson, but it's going to sort of incorporate and review some of the stuff from this quiz just now. So we're starting off today with our do now, and our do now is going to be 4 questions from the quiz yesterday, and they're the 4 questions that the most people missed. I think for all 4 of these, actually, a majority of people, right around a majority, missed each of these 4 questions. You're going to need to kind of write a short free response answer for each of these questions because I'm not going to show you the multiple choice answers. But go ahead and pause the video and answer these 4 questions as best as you can in your notebook now. And I am now assuming that you've unpaused the video, having answered the questions. And I'm going to take each of these 4 questions one by one, showing you the diagrams and kind of reviewing the lessons where we talked about the information and why I expected folks to be able to answer these correctly on our quiz from yesterday. So, number 1. I don't need to go all the way to the end. Whoops. What are you doing, computer? You're going crazy on me. Okay. Number 1. Amy gets some water from the sink. She changes its temperature so that the water's temperature is now below water's melting point of 0 degrees Celsius. What state is the water in? To answer this question, you had to think back to the lesson we had about boiling points and melting points and what those really mean. So this water that Amy got, she got it from the sink, and you assume it was a liquid when she got it, but then she changes its temperature and brings it down below the melting point of 0 degrees Celsius. If we think about our thermometer, when we look at our melting point down here, right, the melting point is 0 degrees Celsius. What that means is that anytime water is below 0 degrees Celsius, it will be solid. Anytime something goes below its melting point, you could also call it a freezing point, it will be solid. So if she took that water and brought it down below the melting point of 0 degrees Celsius, she probably put it in the freezer and froze it so that it was nice and cold and became solid ice instead of liquid water. So the correct answer to this question would be that it was solid. That is the state that that water is in when it's below. Anything that's below its melting point is always going to be solid. Now, if the question said she brought its temperature up, maybe by putting it on the stove, to over water's boiling point of 100 degrees Celsius, then it would be a gas. If it said she made it so that water's temperature was in between its melting point and boiling point, maybe 60 degrees or 20 degrees, and then it would be a liquid. Overall, what you have to remember is that every substance has a melting point and a boiling point, and it is a solid below the melting point, a liquid in between, and a gas when it's above the boiling point. Question number 2. In chemistry, what is a solution? Now, I was disappointed that so many folks missed this one because I feel like we spent a good bit of time practicing solutions and we showed a whole bunch of different examples. But this is where I originally gave the definition for what a solution is. So in our lesson on mixtures, I think it was lesson 7, we learned that a solution is a special kind of mixture where the particles are evenly distributed. And we saw some examples like when we put this sand in water, you could see that all the sand kind of clumped up together at the bottom down below, and so it was not evenly distributed, so it was not a solution. Whereas when we put sugar into water and we stirred it around, all the particles spread out and dissolved and created a solution, so that this one over here is a solution because its particles are distributed, and this one over here is not. Quite a lot of people said when you make a solution, you make a new substance, but that is not correct. That's a chemical change that you're thinking of. I also want to show you this graphic that you're going to see in the video from Crash Course today. So anytime we're making a solution, like this little video right here, if you could zoom in super close, with an imaginary super powerful microscope, what you would see when you make a solution is something like this. Little particles of liquid water, that's what all these blue particles represent, flowing around each other. But spread evenly among those particles now are particles of sugar that have been dissolved and spread evenly throughout the water. This is considered a solution because the particles are, like, you don't see all the sugar particles clumped up together in a pile down here. They're spread evenly among all the water particles. If you could zoom in super close on any solution, that's what you would see. The particles spread together evenly. That's what makes a solution. Question number 3. Sometimes when you combine two things, you get a mixture. But sometimes when you combine two things, you get a chemical change. What is the difference? This is our most recent lesson all about chemical changes, and we're going to be reviewing it even more today. But this is the key point that we had learned before. If you had this written down in your notes, then you knocked out this question. You did great. It was simply that a chemical change is when the particles that make up two or more substances are rearranged to make a new substance. Anytime you're making a new substance when you combine things, you have a chemical change. It's different from a mixture because in a mixture, you just have your old substances mixed together. You don't make anything new when you make a mixture. A solution is a type of mixture, so you don't make anything new when you make a solution. If you make something new, it's a chemical change. We'll be talking more in depth about that today. And this one, number 4. Scientist Dr. Dorothy combines a clear liquid with a blue powder in the laboratory. She observes that the powder dissolves in the liquid and turns a faint blue. Do you think a chemical change happened? Well, the last thing that we learned about chemical changes is that there are 6 signs that you can look for to tell whether or not a chemical change happened. So let's think about the situation that we just read with Dr. Dorothy and try to figure out if we can see any of these 6 signs. First of all, a chemical change can't be undone. That's a little bit hard to tell with this situation because you don't know what it is that she mixed together. You don't know for sure if it can be undone or not. But probably if she just dissolved some powder into a liquid, you could boil it and boil off the liquid and separate. But that's a whole complicated thing. So number 1 doesn't seem like it. Probably not. Let's look for the other ones. Changes in properties such as color or texture. Well, let's see. The powder was blue to begin with, and when she dissolved it into a clear liquid, it turned a faint blue. Well, that's pretty much what we would expect. There's no major changes. Nothing turned green or purple randomly. It's pretty much what we would expect from just blending those two colors together. Does it make smells? No, it didn't say anything about making smells. Does it release light? No, it didn't say anything about releasing light. Did it release gases? No, it didn't say anything about anything fizzing or bubbling or exploding, so it didn't release any gases. And does it give off or take in heat? No, well, it didn't say anything about that either. Basically, there are none of these 6 signs showing up in this little story about Dr. Dorothy. So we have to assume that probably not. This is not a chemical change because none of these 6 signs are observed. And if it was a chemical change, you would probably notice one of these things, and it would be pretty clear. At least one, if not like 2 or 3 or 4. All right. Moving on from that, we're going to stay on this whole idea of chemical changes versus solutions and all that today, and kind of clarify and advance our understanding a little bit more, and mostly today just learn some more vocabulary words. So if you're still confused about solutions versus chemical changes, then I hope today can make things clear. Our big question, the way we're going to frame it today, is what are the different types of changes that can happen? We're going to be talking about 2 main types that you'll hear from Crash Course in just a second. To answer this question, yep, you guessed it, we're going to hop over to our friends at Crash Course. Today is going to be a little bit different because I'm not going to play a whole Crash Course video because she includes too much information for one whole lesson in this video. So I'm going to pause it about halfway, and then we'll get the second half of this video in our next lesson. Listen up.
Even the most dedicated scientist needs a break, right? And in my world, break time means settling down with a nice, cool drink. Whoa, I left a glass full of water here a while ago, and look at it now. It's only half full. Half full. I'm an optimist. But what happened to the rest of the matter? The water, that is, that was in this glass. It looks like it went away. But can that happen? Does matter ever just go away?
For the record, that's the big question that we'll focus on with tomorrow's lesson, but we're going to use the first half of her video to instead focus on this idea of 2 different types of changes.
You already know a lot about matter, like how it can change between different states, like solids, liquids, and gases. You also know that matter can be part of mixtures called solutions. And in solutions, the particles that make up matter become equally distributed in a container, like the sugar and water molecules in our picnic sweet tea. And even though we didn't know it then, that sugar went through what's called a physical change. A physical change is a change in the shape or form of matter. Physical changes do not form a new substance, and they can usually be undone. Like how we were able to separate the sugar from the tea when we heated the tea so that the water evaporated. You also know that matter can go through chemical changes, changes that occur when the particles that make up two or more substances are rearranged to form a new substance. Like, say pancakes or cupcakes or shortcake. I like cake is what I'm saying here. The matter in wet cake batter turns into a new substance, fluffy, yummy cake. There are clues that a chemical change is occurring, like the production of gas bubbles and that delicious smell. And like all chemical changes, we can't undo that change. The process by which chemical change occurs is called a chemical reaction. Scientists, being organized types, give special names to the substances involved in a chemical reaction. The reactants are things that react. They're what get changed during the chemical reaction. And the new substance that's made? That's the product. In our chemical change, the ingredients of the cake contained the reactants, and the cake was one of the products. So, matter can change. But what matter can't do is...
Alright, we're pausing it there because we already got some new vocabulary words, some new understandings of things, and we'll finish off with the rest of it tomorrow. But let's think about what we just learned from Crash Course. The main idea that I want you guys to take away from today's big idea, is that there are two types of changes that we talk about in chemistry. Now, since you all have your notebooks at hand, what I would recommend is, like if this is your notebook page right here with all the lines, is making a T-chart for today. So draw a big capital letter T all the way down the middle that you can then use to organize all the things that you're about to hear about. We'll have physical changes over here and chemical changes over here, and you can write all the different notes that you're about to hear and definitions about each of one. I'd recommend taking a second and organizing your notebook to look like that, so that you can then incorporate all the information from these next few slides. Assuming that you've now done that, let's talk about these two types of changes. First of all, we have a physical change. We also, on the other hand of the T-chart, will have a chemical change. These are two different processes, and we've talked about each of them already, but we've not used necessarily these terms, a physical change and a chemical change. First, we need to define each of them. A physical change is a change in the shape or form of matter, and most importantly, these do not form a new substance. It's just when you have a certain substance, some kind of matter, and you change its shape or its form or its state, but you don't make something new. For the record, we've been talking about these the whole unit, we just haven't used the name physical change yet. But as we're about to see, things like melting water or making a solution are all examples of physical changes. Now, on the other hand, we have chemical changes, and we already know a definition for those. A chemical change is a change that occurs when the particles that make up two or more substances are rearranged to form a new substance. And of course, the new substance is really the key part of this. In chemical changes, you are making something new, a new kind of substance that didn't exist before. Alright, I want to run through a few examples of each of these as well that you can include in your T-chart. Starting with the physical changes, some common examples that we see. Melting something, like melting a bowl of ice cream, is an example of a physical change. You still have ice cream before and after, it's just melted ice cream now. Freezing, of course, which is the opposite of melting, is also an example of a physical change, like freezing water into ice cubes. Ice cubes are still water, they're just in a frozen form. Boiling something is an example of a physical change. And importantly, making a solution is always an example of a physical change. And a lot of you guys got that wrong on a quiz, so make sure you know from now on that anytime we're making solutions, that's a physical change. Those don't count as a chemical change yet, because no new substances get made. For example, if I have a glass of water, let's see how well I can draw here, and I have a packet of Kool-Aid powder, and I pour all the Kool-Aid powder into the water, and I mix it around, and I make Kool-Aid, I haven't actually made, quote-unquote, any Kool-Aid. I haven't made anything new. I just dissolved all those particles of Kool-Aid powder into the water. So I rearranged the form or the shape that they're in, but it's not a chemical change because I didn't really make anything new. I just, put Kool-Aid into a solution form. On the other hand, chemical changes, some examples that we've talked about. The most obvious one we've cited a few times is anytime you bake a cake, you're making something new. You're taking flour and eggs, mixing it all together, and when you bake it, it all combines chemically, the particles combine, and turns into cake. So it's an example of a chemical change. Your body also is going through chemical changes all the time when it digests food. So the food that you eat, your body, your saliva, and when it goes through your intestines, it breaks down the particles that food is made of, and it turns it into proteins and fats and sugars and stuff that your body then uses to help you continue to live. Photosynthesis is something that we talked about a lot earlier this year that is an example of a chemical change. If you remember, we had like a diagram where it looked like a plant that had some leaves on it. Oh my goodness, Mr. Manta needs to be a better artist here. Here, how's this? We had a diagram with a plant with some leaves on it, and we said photosynthesis had some inputs, things that go into it, and some outputs, right? Well, that's the way that a chemical change works we're about to learn. The inputs were carbon dioxide, sunlight, and water, and the outputs were sugar and oxygen as well. So you're making new things. You're making oxygen out of carbon dioxide. So photosynthesis is an example of a chemical change. And lastly, one of the most famous chemical changes that many of you guys have requested that we do as an experiment is elephant toothpaste. You combine different chemicals to create this new thing that people like to joke around and call elephant toothpaste. It has a more fancy chemical name, but hey, maybe we'll talk about that later on. The most important key differences between physical and chemical changes. These are easy to mix up, so I want to be clear, and make sure you write them down. In a physical change, no new substances are created, and therefore they can be undone, because nothing new is being made. Whereas in a chemical change, a new substance is created, and it can't be undone. That's the big difference, like the main key difference between these two different types of changes. And lastly, since you guys want to be able to identify any given change, whether it's a physical or a chemical change, without just listening to Mr. Manta, we need to think about those 6 signs of a chemical change that we talked about. Anytime where there's a physical change, you'll know it's a physical change because it does not meet the 6 signs of a chemical change. Whereas a chemical change would at least meet some of the 6 signs of a chemical change. If you're like, Mr. Manta, what are you talking about? Well, maybe you need to go back and rewatch lesson 9, because we learned when we were talking about chemical changes the first time that there are these 6 signs of a chemical change. That it can't be undone, you have changes in properties like color or texture, it often makes smells, they often release light, they often release gases, and they might give off or take in heat. So those 6 signs are associated with a chemical change, but not a physical change. All right, I want to quickly hit an example, because that's a lot of kind of abstract conceptual stuff, and I want to explain what exactly I'm talking about here and how you can use the information that we just ran through. So let's say that you have a glass, and you fill that glass with a bunch of solid ice cubes, which are just frozen water. That's all that ice is. And then you wait a while, and it gets warm, and all those ice cubes melt, and now you just have a glass of regular liquid water. This would be a physical change. Why? Well, how do I know it's a physical change? Well, let's think about what we just heard. It's a change in the state of matter, right? It's just matter. It's, you have water over here and you have water over here. It's just this is solid water and that's liquid water. That means it's changing state. It can be undone. I could take this water and I could put it back in the freezer and I could turn it back into ice again and just undo the change. Simple enough. That's how ice cubes are made. You can freeze water, you can melt it, you can undo it anytime you want. There is no new substance that was created. We have water over here and you still have water over here, just in a different form. And it does not meet any of the 6 signs of a chemical change. Think about it. When you freeze water, you don't create any smells. It doesn't release light. It doesn't, give off any gases or start fizzing or anything like that. So it's not going to be a chemical change. All right, now let's look at an example of one that is a chemical change. We'll use the same example from a few lessons ago, where we've mixed together a cake batter of flour and butter and eggs and all that kind of stuff, and then we bake it in the oven and we make a cake. This is a chemical change. Let's think about what that means. Why is this a chemical change? Well, a new substance was created. Here you had all these separate ingredients that maybe got mixed together, but you had separate particles of flour and butter and eggs and milk. And now all those things combined together, their particles combined together to create a new substance, which is cake. It can't be undone. It's not possible to unbake a cake the way that you can just, melt ice cubes to undo the freezing of them. You can't go back the other way. That doesn't work. And it meets some of the 6 signs of a chemical change. Specifically, we have a change in properties, right? So like up here, this one is very malleable. It's kind of tan in color, whereas down here it's much more solid. It's brittle, it can crumble, and it's more dark or orange in color. So we have some properties that changed. It usually creates smells when you are baking a cake. If you've ever been near a cake that's baking, it releases gases, and that's how cake becomes kind of spongy and has all those little air pockets in it. And it takes heat to cause this chemical change to happen. If you just leave your cake batter sitting around on the counter all day, nothing's going to happen because you have to put it in the oven and give it a whole bunch of heat in order to cause the chemical change to happen, to make that cake bake. So since it meets some of those 6 signs, we know it's a chemical change. All right, at this point, it's been a while, so we got to hop to classwork question 1. Classwork question 1 is going to feature Jemiah from Purdue, who asked me this excellent question about whether melting ice cream would be a chemical change or not. Well, here it is. Jemiah has a bowl of ice cream that stayed out of the freezer for too long and melted. Which kind of change is this, and how do you know? Pause the video and answer classwork question 1 now. Alright, I'm assuming now that you've answered the question, and we are moving on. The last thing I want to include from today is just some new vocabulary that we're going to be using moving forward. That they mentioned in the crash course video, but I want to be really clear right now. First of all, we have this really fun term. A chemical change can also be called a chemical reaction. And chemical reactions are why people really like chemistry. That's all like the fun, crazy videos you guys have seen, elephant toothpaste and things that explode. Those are all we usually call them chemical reactions. Sometimes it's more useful to call it a chemical change to kind of get at the idea that something is being changed into something else. But if you're watching it happen, most people can be like, oh wow, that was a cool chemical reaction. Every chemical reaction has reactants. The reactants, and you should write down this definition in your notebook, are the substances that you start with. So whatever you start out with, those are your reactants, and then every chemical reaction has products. Those are kind of the opposite of reactants. The definition, which you should write down, is that they are the substances you end up with. So you start with your reactants, you go through a chemical reaction, and you end up with your products. I'll explain what that means in a visual way right here. So let's say that we have some reactants, and who knows what, they could be anything. But we're imagining in this little circle that you're zooming in super close, you're looking at the particles that make up your reactants. So maybe we have a microscope set on some cake batter, we're looking at molecules of flour and sugar, and flour and sugar, and flour and sugar. Those are our reactants, what we start out with. Then we go through this crazy process called the chemical reaction, where particles are rearranging and recombining to make something new, and we end up with products. So we'll say over here that all these particles that we had over here combined and formed these new kind of particles to make a new substance like cake or something like that. And what we've ended up with are products, right? So you always start with reactants, go through a chemical reaction, and end up with products. I'm going to be using those terms all the time from now on, so make sure you understand in your head what those mean. Just to make this a little bit more real, yes, if you had your cake batter right here, anytime you bake a cake or brownies, you're like, hey, Mom, check this out. We have some reactants before you bake it, because those are the things that are going to be going through a chemical reaction. Then when you bake it, that is the chemical reaction. It happens in the oven. And what you end up with, your cake, is a product. The products are what you get at the end after you finish your chemical reaction. Using that information, you're going to answer classwork question 2 right here. This guy Tony does an at-home science experiment where he combines baking soda and vinegar to cause a chemical reaction that creates carbon dioxide gas. In this situation, what are the reactants and what is the product? You don't have to know really anything about all this advanced stuff, baking soda, carbon dioxide, to just tell me, based on what's going on here, what are your reactants and what is the product? That's all you got to tell me. Pause the video and answer classwork question 2 now. Alright, now assuming that you're unpausing, we are moving right along to our independent practice. This is our last bit for today. Make sure you're writing out numbers 1 through 8 in your notebook, and here are your 8 questions. Pause the video and answer these 8 questions in your notebook to the very best of your ability now. Alright, we're now unpausing. I'm assuming that you've answered your questions because I'm showing you the answers. Alright, number 1. There are 2 kinds of change that can happen in chemistry. A physical change and a chemical change. We just spent the whole video talking about those, so I hope you got that one. Number 2, the most important thing about a chemical change is that a new substance is created. If you remember nothing else about chemical changes, think chemical change, new substance. Chemical change, new substance. Number 3, if a change can be undone, then it must be a physical change. Physical changes we can undo. Number 4, a chemical change can also be called a chemical reaction. That's just another name for a chemical change, it's a reaction. Number 5, the stuff you start out with before a chemical reaction are called the reactants. That's that term that we just learned. Number 6, the stuff you end up with after a chemical reaction are called the products. You start with the reactants, you end with the products. Number 7, if you make a solution by dissolving something, you're making a physical change because no new substances are being created. If you're not making a new substance, it's got to be a physical change. And number 8, when you bake a cake, you're making a chemical change because you're making a whole new substance. New substance, chemical change. Always remember that. Alright, as always, start the questions you got correct, fix those ones you got wrong, and in today's classic form, tell me which ones you got right. And that wraps it up for today. It is now exit ticket time. Go ahead and answer the questions for our exit ticket. Those will be graded as always. And for today's cool thing, I wanted to throw back to a couple days ago when I had you guys say good morning to me in all those foreign languages in the comments. I was really impressed. And I posted this in the comments as well, which is kind of like a little riddle, trying to see if anyone could figure out what language I was using. The only student who got it was Chris Perkins in Purdue, so congratulations, Chris. This right here is an example of a language called Morse code that was invented in like the early 1900s. That was like a really early form of electronic communication. But if you want to check out and write some Morse code yourself, I'll put a link to a Morse code translator where you can type any words that you want, like hello world, and it will translate it to Morse code down here. It's a whole language that's written just with dots and dashes. And you can also play it out loud. So if you were to play this sequence here, dot, 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 dash, dot, dot, it would sound like this. And that is what it sounds like to say hello world in Morse code. It's pretty neat. You can go around and play around with yourself, maybe write some secret messages to people, but keep it school appropriate. Alright folks, that's all that we got for today. I will see you folks at our next lesson.